All right, so what we've got here is we're dealing with our production possibilities curve, and we have cakes and muffins. Those are going to be our two items that we are producing here. So we have cakes along our y-axis, muffins along our x-axis. And the first thing we should do whenever we have information like this is we should plot out our points. And so if you notice, we have point A, where if we put all of our resources toward producing cakes, we can produce 4 cakes, but then we wouldn't be able to produce any muffins. We also have a point where we kind of split up our resources a little bit, and we can produce 6 muffins and 3 cakes. That's point B. We could split them up a little bit more, and we could have 2 cakes and 12 muffins at point C. Point D would be us having 1 cake and 18 muffins. That's point D. And then if we put all of our resources just toward producing muffins, point E shows us that down there. And so all we've done is taken these points in this table, plotted those out, and then what we're going to do is we're going to connect those points. And connecting those points is going to give us our production possibilities curve right there. And so we've got our production possibilities curve. And one thing we notice here, it is linear, it is straight, and that's because we have a constant opportunity cost. And that's something we talked a little bit about in 1.3, but it means that for every single cake that we add, we're always giving up the same number of muffins. Now it asks us to draw and label 3 separate points, a point X of inefficiency, Y that's unattainable, and Z that's a point that represents efficiency. Well, a point that is inefficient would be any point that falls inside of our production possibilities curve. So you can really put that point X anywhere. We could put it right here, call it point X, and that would be inefficient. And the reason is that any point inside of our production possibilities curve means that we have the resources to do that, but we're obviously not using all of our resources. Using all of our resources is represented by the line. So anything inside of that line means, yeah, we can do it, we're just not using all those resources. Point Y needs to be a point that's unattainable, and that would just be any point that is out here outside of our production possibilities curve. It can go anywhere on the outside, and that just means that we don't have enough resources to produce out there. Like we couldn't make, say 3 cakes and 18 muffins because we don't have enough of the cake mix, right? A point Z then just needs to be any point that is efficient. And so point Z can fall anywhere along our curve because our curve represents full efficiency. That's kind of one of our rules with our production possibilities curve, is that any point along the curve represents us being fully efficient with our resources. So let's start here. What is our opportunity cost of moving from point D to point A? Now, a few things to keep in mind with this. The direction that we move is incredibly important because we're moving from point D here to point A. And like I said, the direction matters. And the direction matters because whenever we're moving a certain direction, we're going to gain more of one item, but then we're going to be giving up some of the other. And remember, a cost is whatever we have to give up. So if you notice from D to A, at point D, we start with 1 cake, but we move our production and we start making 4 cakes. Now, in order to start producing 4 cakes, we're going to have to shift around some of our resources. Because if you notice, we used to be producing 18 muffins. Now, if we start making more cakes, we won't be able to make any muffins. So while we add 3 cakes for ourselves, that's not our opportunity cost because we're gaining that. Remember, your costs is what you give up. And in this case, we give up 18 muffins. We lose 18 muffins going from D to A, and therefore our opportunity cost of moving from point D to point A is 18 muffins. Well, what is our opportunity cost for our first 9 muffins? So there's a couple different ways that we could actually do this one, and I'm going to start off by showing us kind of one way with here on the table, and then we'll show another way later. So we say for our first 9. So first 9 implies that we haven't made any yet, but we're going to start making 9. But if you notice, 9 doesn't show up on here. But what we can do is we can say, okay, well, we know that 9 comes halfway between 6 and 12, kind of right in there. Well, then what comes between 3 and 2 right above it? Well, it'd be 2.5, right? So if we're moving from 0 muffins, because it's going to be our first 9, so we haven't made any yet, up to 9, we're adding 9 muffins, but that is not our opportunity cost. Opportunity cost is what opportunity are we giving up? Well, we're giving up the opportunity to be producing all of those cakes because we used to be able to produce 4. Now we can only produce 2.5. So we're giving up 1.5 cakes. Therefore, our opportunity cost is 1.5 cakes. Now this says here, what is our opportunity cost of just a single cake? So we're looking at our opportunity cost just for one cake here. Now here's how we need to get familiar or comfortable with setting this up. What we're going to do is we're going to look at this, and we're going to look at the two extreme ends here. So we've got this point right here. We've got this point right here. And we're saying, okay, we know that if we use all of our resources toward just producing cakes, we can produce 4 cakes, right? And that uses all of our resources. Now we could take those exact same resources and only put them toward muffins. It would produce us 24 muffins. And so therefore we can set 4 cakes equivalent to 24 muffins, because we said right above, those two things use the exact same resources. And we also see that if any time, like if we wanted to move from, say, point E to point A, if we wanted to add all 4 of our cakes, we would have to give up all 24 of our muffins, right? And so that's why we can set those things equivalent to one another. And so this shows us our opportunity cost for all 4 cakes, but what if we want to know what's our opportunity cost for just a single cake? Well, what we can do is we can divide both sides by 4, because if you notice, the 4's over here cancel out and they give us 1 cake here. And then we have 24 divided by 4 gives us 6 muffins. So we know the opportunity cost for 1 cake is going to be 6 muffins. Now it then asks us what's our opportunity cost of just 1 muffin. Well, if we go back up here and let's rewrite this equivalency. Like we said, we know that 4 cakes is equivalent to 24 muffins. But if we want this just to say 1 muffin over here, what do we divide both sides by? If we want this to say 1 muffin, well, we can divide both sides by 24, because the 24s cancel out and give us 1 muffin, and that's equivalent to 4 over 24 cakes. Well, what's 4 divided by 24? Well, if you get the 4's out of there, it's 1/6 of a cake. So the opportunity cost for 1 muffin is 1/6 of a cake. And if you notice, these two are reciprocals of one another, and that is always going to be the case. Now, like I said earlier, I wanted to show you a way where you could solve that other question. This one earlier where we say, what's our opportunity cost for 9 muffins? Well, if it's for 9 muffins, we know that the opportunity cost of just 1 muffin is 1/6 of a cake. So we can say, okay, well, we know 1 muffin, the opportunity cost for that is 1/6 of a cake. But we want to know it for 9 muffins. What we can do is we can just multiply this side by 9 and multiply this side by 9. And what we end up with is 9 muffins is equivalent to 9 over 6 cakes, which simplifies down into 1.5 cakes, which is exactly what we had set up there.